For nearly 40 years, we thought we knew Uranus. One flyby, a few grainy photos, a boring blue-green ball with no storms, no excitement, nothing to see. We were wrong. New data, some of it just released, is rewriting everything scientists thought they understood about this planet. There's a hidden ocean world orbiting it that nobody expected. There's a magnetic field so broken it barely makes sense. And there's a brand new moon that was invisible to us until one of the most powerful telescopes ever built finally caught it. Today, we're going inside Uranus, literally, to find out what NASA actually discovered and why it might force us to rethink an entire planet. Let's rewind. In January 1986, NASA's Voyager 2 became the only spacecraft in history to fly past Uranus. It got one shot, snapped its photos, and kept going toward Neptune. And what it saw was nothing. A smooth, featureless, pale blue-green marble. No storms, no dramatic bands like Jupiter. Just a quiet, boring giant. For decades, that was the story. Uranus was the planet scientists skipped over, sandwiched between spectacular Saturn and mysterious Neptune, with almost no funding, no dedicated missions, and no real interest. But here's the twist. That boring flyby happened during a freak solar wind event that was actively squeezing and distorting Uranus's magnetic field at the exact moment Voyager 2 flew by. In other words, we judged an entire planet based on one bad timing snapshot, like judging someone's personality from a single bad day. Scientists have known this for a while, but it's only recently, using new tools, that we've started correcting that first impression. Let's start with the magnetosphere, basically the planet's magnetic force field. Every planet with a magnetic field has one that roughly lines up with its spin axis. Earth's does, Jupiter's does, Uranus's does not. Uranus itself is already famous for spinning on its side, tilted about 98 degrees, so it basically rolls around the sun like a barrel instead of spinning like a top. But its magnetic field is tilted again, by about 60 degrees relative to that rotation axis, and it isn't even centered on the planet's core. That means as Uranus rotates, its magnetic field wobbles and flexes like a poorly balanced tire. Sometimes, its magnetic poles point almost directly at the sun. Other times, they're sideways. This creates a magnetosphere that opens and closes rhythmically, letting solar wind particles leak in and out in a way no other planet in the solar system does. Newer observations, including infrared images from the James Webb Space Telescope, have captured the auroras this creates, glowing in Uranus's upper atmosphere. Unlike Earth's auroras, which form neat rings near the poles, Uranus's auroras show up as strange shifting patches because the whole magnetic geometry is off-kilter. Scientists are using these glows to map temperatures and activity deep in the planet's atmosphere for the first time. Basically, Uranus's insides are so strange that even its magnetic field can't seem to organize itself properly. So what's actually inside the planet? Uranus and its twin, Neptune, are called ice giants. Not because they're made of ice like your freezer, but because their interiors are thought to be dominated by hot, dense fluids of water, ammonia, and methane, wrapped around a rocky core, all buried under a thick atmosphere of hydrogen and helium. Under the extreme pressure inside Uranus, scientists have long theorized something wild. Methane in the interior could get squeezed so hard that carbon atoms separate out and crystallize, creating literal diamond rain falling through the planet's interior. Lab experiments recreating those pressures here on Earth have produced small diamonds this way, which is part of why the theory persists. We haven't directly observed this happening inside Uranus itself, but it's one of the most compelling explanations for the planet's unusual internal structure. There's also debate over whether Uranus has an actual internal heat engine at all. Unlike Jupiter, Neptune, and Saturn, Uranus radiates barely any extra heat beyond what it receives from the sun. Some scientists think this could be evidence of a stable, layered interior where heat gets trapped rather than convecting to the surface, possibly linked to giant ancient impacts early in its history that scrambled its interior. This is still one of the biggest open questions in planetary science. None of this is confirmed the way, say, Jupiter's storm bands are confirmed, but it's why researchers are pushing so hard for a dedicated Uranus mission. Because right now, we're mostly working from a single 1986 flyby and educated guesses. Here's where it gets genuinely exciting. Uranus has a family of moons named after Shakespeare and Alexander Pope characters. Miranda, Ariel, Umbriel, Titania, and Oberon are the 5 big ones. For a long time, we assumed they were just cold, dead ice balls. But reanalysis of old Voyager 2 data, combined with newer modeling, suggests that several of these moons, especially Ariel and Miranda, may have subsurface oceans of liquid water beneath their icy crusts, kept liquid by internal heating from tidal forces and possibly radioactive decay. Miranda in particular has bizarre jumbled terrain, cliffs, canyons, and patchwork surfaces that look like the moon was shattered and reassembled, which is exactly the kind of geology you'd expect if something dynamic were happening underneath. If that holds up, Uranus wouldn't just be an oddball ice giant. It would be sitting at the center of its own mini-system of potentially habitable ocean worlds, similar in spirit to what we've found around Jupiter and Saturn. And then, in 2025, came a discovery that made headlines. Astronomers using the James Webb Space Telescope found a brand new moon orbiting Uranus, provisionally named S-2025-U1. It's tiny, only around 6 miles across, and orbits so close to the planet, tucked between 2 other small moons, that it was completely invisible to Voyager 2 and every telescope, until Webb's infrared camera finally caught it in a series of long exposure images. This brought Uranus's total known moon count to 29. That's the story here. Even after 40 years of study, this planet is still hiding things in plain sight. Before Voyager 2 even got there, astronomers already knew Uranus had rings, discovered by accident in 1977 when scientists watched the planet pass in front of a distant star and noticed the star's light blink several times before Uranus itself blocked it. That blinking pattern revealed a set of narrow, dark rings. Unlike Saturn's bright, icy rings, Uranus's rings are dark, thin, and made of larger, coal-black particles, which is part of why they went unnoticed for so long through ordinary telescopes. Since then, more rings have been found, and the James Webb Space Telescope has captured some of the clearest images yet, showing the rings glowing brightly in infrared alongside the planet's faint moons. It's a reminder that this boring planet has had surprises hiding in its structure for decades. We just needed better tools to see them. So why should any of this matter to you? Here's the bigger picture. Ice giants like Uranus and Neptune appear to be one of the most common types of planet in the entire galaxy. Many of the exoplanets astronomers have found orbiting other stars are close in size and mass to Uranus. Far more common than gas giants like Jupiter or rocky worlds like Earth. That means understanding what's really happening inside Uranus isn't just about one weird sideways planet in our own backyard. It's about understanding an entire category of world that might be the galaxy's default planetary blueprint. Every discovery, the broken magnetic field, the possible ocean moons, the newly found satellite, helps scientists build a model for ice giants everywhere, not just the one we can currently reach. That's exactly why there's growing momentum, including recommendations from NASA's own planetary science community for a dedicated orbiter mission to Uranus, something that could finally replace one 1986 flyby with years of continuous close-up observation. For 40 years, Uranus was the planet nobody paid attention to. Today, it might be one of the most important planets we can study, a window into hidden oceans, broken magnetic fields, and the most common type of world in the galaxy. We went in expecting a boring ball of gas. We found a planet that's still full of secrets. If you want to see what NASA finds next, make sure you're subscribed, because Uranus isn't done surprising us yet.